Welcome to Math with Wong. Today we're going to look at number 9 of the May 2024 standard level paper 1. As you can see, this is a probability question. It says here a bag contains the buttons which is either red or blue. Initially, the bag contains 3 red and 1 blue. Francine here randomly selects one button from the bag. She then replaces the button. That's a keyword. That means this is with replacement. You put it back in. She then replaces the button and adds one extra button of the same color. Now, that's a wrinkle. We don't generally have things like that, so you have to pay attention. It says not only do you put it back, you have to put one more in. That's the same color as the one that you just took out. For example, if she selects a red, she then replaces the red back and adds one extra red button. So now you would have 4 red for the next draw and 1 blue still. Okay. They then give you a tree diagram. They did the top half and asked you to fill out the bottom half. So here you have 3 red and 1 blue initially. If you pick a red, then you need to put the red back in and add another red. So now you have 4 red and 1 blue. That's what's happening here. So the probability of getting red is now 4/5, and the probability of getting blue is 1/5. Now, if the first draw is blue, then not only do you need to put a blue back, you need to add another one. So now I'm going to have 2 blues for the next draw, but I still going to have the 3 red. So the probability of drawing red would now be 3/5. And the probability of drawing blue would now be 2/5. And that's going to be part A. Find the value of P and Q. Part B, find the probability that Francine selects 2 buttons of the same color. Right? That's an IB favorite. Whenever they say same color, that means there are 2 possibilities. You can have a probability of a red and a red. I'm going to use R, not A and B. Probability of red and red. And you can have a probability of blue and blue. And you're going to add those 2 together. So when you go back to the tree diagram, what we want is we want this branch. That's red and red, which means it's going to be 3/4 multiplied by 4/5, which is going to be 3/5. And we want blue and blue, which is this branch. That is going to be 1/4 multiplied by 2/5, which is 1/10. And we're going to add those 2 numbers together. So 3/5 plus 1/10 is going to equal to 6/10 plus 1/10, which is 7/10. And that's how we show that the probability that Francine selects 2 buttons of the same color is 7/10. Now, part C, you have a keyword of given that. Anytime you see given that, that's a keyword given by IB that tells you that this is a conditional probability. Anytime you have a conditional probability, the condition becomes your denominator. And the condition is she selects 2 buttons of the same color, which is what you just calculated in part B. Or if you don't know the answer, they gave you the answer, you're going to put the 7/10 in the denominator. Now, what goes into the numerator? Well, what goes in the numerator is that she selects 2 red buttons. So the probability of red and red goes on top. So what's the probability of red and red? It's 3/5. So 3/5 would go to the numerator. That's the probability of red and red, divided by the condition, which is the probability of the same 2 buttons of the same color. So divide by fraction is multiplied by its reciprocal. 5 and 10 reduce, so that's going to be 6/7. Part C is going to be 6/7. The second half of the question, we're looking at a probability distribution. We are provided with a random variable x, which is the number of red buttons. So you can have 0 or 1 or 2. So if you go back to the tree diagram, this would be 2 red buttons. The 2 middle ones is going to be 1 red button, and the one down here would be 0. So probability of 2 is 3/5. Probability of 0 is 1/10, which it's filled in already. So we need the middle one. That's the probability of 1. We need 3/4 times 1/5. That's 3/20. Here we have 1/4 times 3/5. That's also 3/20. So if I add them up, I'm going to get 6/20. Or 3/10. So therefore, A is equal to 3/10, and B is equal to 3/5. Right? You can always double check. The sum should be 100%. So this is 1/10. That's 3/10. That's going to be 6/10. Together, you're going to get 10/10. Part E, we are looking at expectation. Expectation is multiplying that. So you take 0 multiplied by 1/10 plus 1 times 3/10 plus 2 times 3/5 or 6/10. And you're going to get 3/10 plus, what do we say? 6/10. No, 6/5. 2 times 6/10, so 6/5, or 12/10. So 12/10 plus 3/10 is going to be 15/10, or 3/2. So the expectation is 3/2. The expected number red would be 1.5. That is part E. The third part of the question, it says here, Francine, we start the process with 3 red buttons and 1 blue button, just like before. She selects 1 button, just like before, replacing the button and then 1 extra button of the same color each time. She repeats this until she selects a blue button. Okay, so this keeps on going until you get a blue. Given that the first 2 buttons she selects are red, so we're looking at this scenario. The first one's red, the second one's red. Now we're here. Given that the first 2 buttons she selected are red, write down the probability that the next button she selects is a blue. So we want to know what is the probability that you're going to get a blue for the next draw. Well, we need to know that in total, you're going to have 6. Out of the 6 different buttons, now you're going to have 5 red and 1 blue, right? Because the first one was red, you put another red. The second one is red, you put another red. So now you're going to have 5 red and 1 blue. So the probability of getting a blue in this particular sense for part F is going to be 1/6. The last question here. the probability that she selects the first blue button after n selection, so we don't know when it is 3 over 56. Find the value of n. So what we can do, right, the long way is you can kind of like do trial and error. So this one was like 3 over 4 times 4 over 5 times 1 over 6. If you do the next one, this is like on the third try, you are successful. If the fourth try you are successful, it would be 3, 4, 4, 5, and then 5 over 6, which means now you have 7, and 1 out of the 7 is blue, right? And then the next one, it's going to be 5. So 3 over 4, 4 over 5, 5 over 6, 6 over 7, and you're going to be multiplied by 1 over 8. Now, the good news you see here is that those cancel. This and that reduce. So this is 1 over 10. Those cancel. This is reduced. So that's going to be 1 over 14. Those cancel. That's going to be 3 over 56. Oh, this is going to be the correct answer. So it's going to be 5 tries. Now, you say, I don't want to do trial and error. Well, if you don't want to do trial and error, then you have to set up using the letter N. So you have to see what's the relationship. Well, the relationship is you're always going to start with 3 over 4. That's not going to change. The next one is going to be 4 over 5, and so on and so forth, right? How do I know when to stop? Well, the last one is always going to be 1 over this. See how 5 and 8, 4 and 7, 3 and 6. So this is always 3 more than whatever the n is. The second last term is going to be 1 less than this guy. So it's going to be n plus 2, and that's going to be n plus 1. And the good news is you see how everything cancels. So all those things is going to cancel each other, and you're going to left with 3 over n plus 2 multiplied by 1 over n plus 3, and that has to equal to 3 over 56. So you're going to have a quadratic, then you need to expand and simplify. So here, cross multiply 3 times 56 is equal to 3 times n plus 2 times n plus 3. Divide both sides by 3. Expand. I'm going to add n squared plus 5n plus 6. Bring the 56 to the other side. Is going to be minus 50. Like, what two numbers will work in this scenario? 5 and 10, x plus 10, x minus 5, or n plus 10, n minus 5. Well, n cannot be a negative number, so that's not acceptable. But n can be a positive number, so n is equal to 5. So that's solved using kind of like more of an algebra systematically, but that's like trial and error, and the value of n would equal to 5. Okay, so this is the probability question where it includes a tree diagram, a conditional probability, a probability distribution, expected value, and here, last bit here is a little bit of a thinking question, understanding what to do, or you can do trial and error, but following a pattern. Okay, so that's number 9 on the exam. Thank you for watching.